Hi all, welcome to the new video of computer network. In this video we are going to discuss transport layer protocols. The transport layer is represented by two protocols, TCP and UDP, that is transmission control protocol and user datagram protocol. First one we are going to discuss UDP. The UDP stands for user datagram protocol. It is a simple protocol and it provides non-sequential transport facility. It is a connectionless protocol. It is important point. It is connectionless protocol. This type of protocol is used when reliability and security are less important than speed and size. UDP is an end-to-end transport level protocol that adds transport level address, checksum, error control, and length information to the data from the upper layer. The packet produced by the UDP protocol is known as a user datagram. Now we are going to discuss user datagram format. The user datagram has a 16-bit header which is shown below, and here we have source port address, destination port address, total length 16 bits, checksum 16 bits, and data. Now source port address 16-bit, it defines the address of the application process that has delivered a message. The source port address is of 16-bit address. Now destination port address, it defines the address of the application process that will receive the message. The destination port address is of a 16-bit address. Now total length 60-bit, it defines the total length of the user datagram in bytes. It is a 16-bit field. Now checksum 16 bits. Checksum is a 16-bit field which is used in error detection. So this is the user datagram protocol format. Now we are going to discuss disadvantages of UDP protocol. UDP provides basic functions needed for the end-to-end delivery transmission, and it does not provide any sequencing or reordering functions and does not specify the damaged packets when reporting an error. And next point, UDP can discover that an error has occurred, but it does not specify which packets has been lost, and it does not contain an ID or sequencing number of a particular data segment. So these are the disadvantages. Now we are moving to next protocol, that is transmission control protocol, TCP. TCP stands for transmission control protocol. TCP provides full transport layer services to applications, and TCP is a connection oriented protocol, means the connection established between both the ends of the transmission, that is source and destination. For creating the connection, TCP generates a virtual circuit between sender and receiver for the duration of transmission. Now we are moving to TCP segment format. It follows the following diagram, and it's having source port address 16 bits. It is used to define the address of the application program in a source computer. It is a 16-bit field destination port address, and it is used to define the address of the application program in a destination computer. It's a 16-bit field. Now destination port address, it's also similar to source port address. It's a 16-bit field for storing destination port address. Then sequence number, a stream of data is divided into two or more TCP segments. The 32-bit sequence number field represents the position of the data in the original data stream. Acknowledgement number, now this is a 32-bit field. Acknowledgement number acknowledges the data from other communicating devices. If ACK, that is acknowledgement field, is set to 1, then it specifies the sequence number that receiver is expecting to receive. Now header length, HLEN, it specifies the size of the TCP header in 32-bit words. The minimum size of the header is 5 words and the maximum size of the header is 15 words. Therefore the maximum size of the TCP header is 16 bytes and minimum size of TCP header is 20 bytes. Now reserved bits, that is, it's a 6-bit field which is reserved for future use, and Yeah, we have URG, ACK, PSH, RST, SYN, FIN, etc. Then control bits. Control bits. Each bits of a control field functions individually and independently. A control bit defines the use of a segment or serves as a validity check for another fields. There are total six types of flags control field in TCP protocol. First one, URG. The URG field indicates that the data in a segment is urgent. ACK. When ACK field is set, then it validates the acknowledgement number. PSH. The PSH field is used to inform the sender that higher throughput is needed. So, if possible, data must be pushed with higher throughput. Now RST, the reset bits is used to reset the TCP connection when there is any confusion occurs in the sequence numbers. Then SYN field used to synchronize the sequence numbers in three type segments: connection request, connection confirmation, and confirmation acknowledgement. Now FIN, this field is used to inform the receiving TCP module that the sender has finished sending data. It is used in connection termination in three types segments: termination request, termination confirmation, and acknowledgement of termination confirmation. Now we are going to discuss difference between TCP and UDP. So here we have three columns basic for comparison: TCP and UDP. So first category, definition. TCP establishes a virtual circuit before transmitting data. UDP transmits the data directly to the destination computer without verifying whether the receiver is ready to receive or not. Now, connection type parameter. It's a TCP is a current connection oriented protocol and UDP is a connectionless protocol. Now, speed. TCP is very slow, UDP is very high. Now, reliability. TCP is a reliable protocol. UDP is an unreliable protocol. Header size. Header size of TCP is 20 bytes. Header size of UDP is 8 bytes. Acknowledgement. TCP waits for the acknowledgement of data and has the ability to resend the lost packets. UDP neither takes the acknowledgement nor it retransmits the damaged frame. So thank you. I will come with next layer of computer OSI model, computer network OSI model in the next class. Thank you all.